After completing this section, you should be able to achieve the objectives shown on this slide. By demonstrating competence in managed switch operation, you should be able to understand how a managed switch works, the role of the different management protocols, and the 40-switch auto-discovery and authorization process. Managing 40-switch devices using FortiGate offers the following important key benefits. Zero-touch provisioning. When you connect FortiSwitch to a FortiGate interface with FortiLink enabled, FortiGate automatically discovers and provisions FortiSwitch. If you use FortiManager, you can also achieve zero-touch provisioning by configuring the FortiGate settings on FortiManager. Secure configuration management. All FortiSwitch management is done on the FortiGate GUI and CLI, or on FortiManager if you are using it. Administrators are not required to log in to FortiSwitch. Centralized provisioning and maintenance. FortiSwitch becomes an extension of FortiGate. You can configure firewall policies using FortiSwitch VLANs the same way you configure firewall policies for FortiGate VLANs. Authentication and authorization are also handled centrally on FortiGate or FortiManager. FortiSwitch Virtual Stack. FortiGate can manage a logical FortiSwitch virtual stack in different ways to offer scalability and redundancy. Model range. FortiGate and FortiSwitch devices are available in different sizes to accommodate the needs of customers ranging from retail and SMB customers to data centers. Before you can manage your FortiSwitch virtual stack on FortiGate, you must enable the switch controller feature so FortiGate can discover and manage connected FortiSwitch devices. In addition, you must make sure the FortiSwitch OS version of your switch is compatible with the FortiOS version of your FortiGate. You can check the FortiSwitch OS and FortiOS compatibility matrix on docs.fortinet.com. The switch controller feature is enabled by default on most FortiGate models. In FortiGate VM models, however, it is not enabled by default, but you can enable it using the CLI commands shown on this slide. After you enable the switch controller feature, the related switch controller settings are shown on the GUI. If the GUI settings are not shown, make sure that the switch control feature is enabled. To manage FortiSwitch on FortiGate, the switch must be connected directly or indirectly to a FortiLink interface on FortiGate. The FortiSwitch side of the FortiLink interface is called the FortiLink trunk. You will learn more about FortiSwitch trunks in another lesson. A group of managed switches that are connected to the same FortiLink interface is called a FortiSwitch virtual stack. There are multiple ways you can connect the switches together and to FortiGate. You will learn about the different network topologies supported in another lesson. Switch management traffic between FortiGate and the FortiSwitch virtual stack travels through the FortiLink interface. In addition, user inter-VLAN and Internet traffic from endpoints connected to the FortiSwitch virtual stack, as well as traffic destined for FortiGate, also travels through the FortiLink interface. You can create multiple FortiLink interfaces on a FortiGate to manage multiple FortiSwitch virtual stacks. You can create the FortiLink interfaces in the same VDOM or different VDOMs. You can manage FortiSwitch devices on a FortiGate device configured in standalone or HA mode. Both HA modes, active-passive, AP, and active-active, AA, support switch management. However, the VDOM in which you configure the FortiLink interface must be operating in Network Address Translation, NAT mode. You cannot manage FortiSwitch devices on a transparent VDOM. Regardless of the network topology in which you deploy your managed FortiSwitch virtual stack, it resembles a router-on-a-stick topology. The switch virtual stack is connected to the FortiGate FortiLink interface, and therefore, all traffic between the virtual stack and FortiGate is sent over this link. From a logical perspective, the intra-VLAN traffic is handled by the switch virtual stack. Because FortiGate is usually the default gateway for the endpoints connected to the switch virtual stack, inter-VLAN traffic, Internet traffic, and any other traffic that FortiGate protects is sent to FortiGate through the FortiLink interface. FortiGate then processes the traffic, based on the configured routing settings, firewall policies, and other related settings. For inter-VLAN traffic, FortiGate receives the user traffic tagged with the VLAN ID of the incoming VLAN interface, forwards the user traffic out of the outgoing VLAN interface, and tags it with the VLAN ID of the interface. In addition, the switch management traffic is exchanged untagged and assigned to VLAN 4094 by default. VLAN 4094 is configured as the native VLAN on the FortiLink trunk, inter-switch links, ASL, and inter-chassis links, ICL. You will learn more about VLANs, FortiSwitch VLANs, ISLs, and ICLs in another lesson. On FortiOS with FortiSwitch OS version 7.4 and later, FortiGate can perform inter-VLAN routing on a managed FortiSwitch. You can apply inter-VLAN routing offload to the FortiSwitch that is closest to the FortiGate that manages it. Inter-VLAN offload routing is supported on specific models. To verify which FortiSwitch models support inter-VLAN offload routing, you can check the FortiLink compatibility table. All FortiGate devices that support the switch controller feature come with a factory default FortiLink interface in the root VDOM named FortiLink. The default FortiLink interface is a link aggregation group, lag interface with no lag members by default. As a result, you must add the lag members manually. The interface is also assigned the 10.255.1.1/24 address by default. FortiGate uses the address and net mask to configure a DHCP scope for assigning addresses and other network parameters to managed switches. In addition to acting as the default gateway and DHCP server for the managed switches, FortiGate also becomes the DNS and NTP server by default. Note that even though the DHCP server is set to specify in the default DNS server configuration, this setting automatically changes to same as interface IP after you apply the initial changes to the FortiLink interface. By default, you must authorize the switches that FortiGate discovers before you can manage them. Alternatively, you can enable automatically authorized devices to automatically authorize discovered switches. In addition, FortiLink split interface is enabled by default. When there is a FortiLink interface with two or more members, this option instructs FortiGate to keep only one FortiLink interface member active. This behavior is useful when you connect the FortiLink interface from one FortiGate device to two or more switches, and the switches do not support multi-chassis link aggregation group, MC-lag, or MC-lag is not configured. In this scenario, you lose management to one or more switches if the FortiLink split interface is disabled. You will learn more about MC-lag and redundant network topologies in another lesson. Finally, the GUI also displays a status icon. If the FortiLink interface is a lag, then the icon indicates the status of the lag. FortiGate uses multiple protocols to control FortiSwitch. The protocols listed on this slide are used mainly for switch discovery, authorization, and health checks. For discovery, FortiGate uses the FortiLink protocol by default. The FortiLink discovery frames include the switch serial number as well as the port information on the switch. Note that when FortiSwitch is in standalone mode, all ports send FortiLink discovery frames by default. For more information, refer to the FortiSwitch, managed by FortiOS document on docs.fortinet.com. FortiLink is also used by managed switches that are directly connected to FortiGate to send heartbeats. You can also use LLDP as an alternative switch discovery method. LLDP is also used when setting up a switch virtual stack because it enables the links connecting the switches to be automatically configured as trunks, auto ISL. You will learn more about trunks and auto ISL in another lesson. Control and provisioning of wireless access points, CAPWAP, is another control protocol that FortiGate uses to manage FortiSwitch devices. CAPWAP performs switch authentication, authorization, and health checks, heartbeats, by establishing a datagram transport layer security, DTLS tunnel between FortiGate and the switch. It is also used as an alternative and legacy method for sending a firmware image file to a switch when you use the FortiGate GUI firmware upgrade tool. FortiSwitch also uses CAPWAP to send LLDP neighbor information and switch logs to FortiGate. FortiLink supports both CAPWAP, default, and HTTPS-based management for FortiSwitch devices. CAPWAP is ideal for plug-and-play provisioning. Alternatively, HTTPS management, TCP/443, provides a more secure option, especially in environments where CAPWAP traffic is restricted. This allows FortiGate to manage FortiSwitch devices using encrypted communication, enhancing security. DHCP, DNS, NTP, and HTTPS are used for provisioning and are essential for the proper operation of the switch. They also provide a management IP address, time synchronization, name resolution, and configuration, respectively. FortiGate acts as the switch's DHCP, DNS, and NTP server. FortiSwitch uses DHCP to get an IP address from the same subnet as the FortiLink interface. In addition, FortiGate is configured to respond to DNS and NTP requests received at the FortiLink interface by default. Using NTP is very important because the time on FortiGate and FortiSwitch must be in sync. Otherwise, the CAPWAP DTLS tunnel might not be established, and the switch won't come online. FortiGate uses HTTPS to push switch configuration, collect diagnostics, and act as the switch's default firmware upgrade method. For this, FortiGate uses the FortiSwitch REST API to communicate with the switch. For example, when you change the port configuration of a switch on FortiGate, FortiGate uses the FortiSwitch REST API to apply the changes to the switch. When you check the FortiSwitch ports on the GUI, FortiGate also uses the FortiSwitch REST API to obtain the current port status information from the switch. When you use the FortiSwitch firmware upgrade tool on the FortiGate GUI or CLI, FortiGate uploads the firmware image file to the switch through HTTPS. Finally, FortiGate also uses SSH to access the switch CLI. When you use the CLI connection tool available on the GUI, FortiGate establishes an SSH connection to the switch management IP address. FortiGate can discover FortiSwitch, regardless of the FortiSwitch management mode. By default, every FortiSwitch broadcasts FortiLink discovery frames on all ports. FortiLink discovery frames contain information about the switch that FortiGate uses to create the switch configuration on the firewall. FortiGate discovers the switch after it receives FortiLink discovery frames from it. At this point, the administrator can authorize the switch for management purposes. If you want to disable auto-discovery on one or more ports, you can log into the switch and then disable auto-discovery FortiLink on the port so FortiGate cannot discover the switch through that interface. When you authorize a switch that is working in standalone mode, the switch management mode changes to Managed Switch Mode, FortiLink mode. When FortiSwitch changes to Managed Mode, it runs the default FortiLink configuration. As a result, the configuration that the switch was running in standalone mode is replaced by the configuration pushed by FortiGate. Also, Auto Network enables Auto ISL on all ports. For this reason, FortiSwitch automatically creates a trunk with the ports that connect to the FortiLink interface as members. If automatically authorized devices is disabled on the FortiLink interface, you must manually authorize a switch on the FortiGate GUI or CLI before you can manage it. To authorize a switch on the FortiGate GUI, click Wi-Fi and Switch Controller, Managed FortiSwitches, select the switch you want to authorize, and then click Authorize. Alternatively, you can right-click the switch to display a context menu, and then click Authorize. You can also use the FortiGate CLI to authorize a switch by enabling the FSW11 admin setting under the Managed Switch configuration, as shown on the slide. Note that when you authorize a switch, FortiGate instructs the switch to set the management mode to FortiLink mode by sending a FortiLink frame to the switch. If, at this point, the switch is operating in local mode, 40 switch automatically changes the management mode to 40 link mode. This slide describes the switch auto-discovery and authorization process when you connect 40 switch in standalone mode to FortiGate. FortiGate has automatically authorized devices disabled. In addition, the example on this slide indicates the serial number of each device, as well as the port used on 40 switch to connect to FortiGate. Based on the example, the process is as follows. 1. 40 switch sends 40 link discovery frames to FortiGate. The frames are sent every 5 seconds and contain the switch serial number, model number, and firmware version. 2. After it receives the 40 link discovery frames, FortiGate adds the configuration of the newly discovered switch to FortiOS. The switch serial number, also known as the switch ID, appears in the list of managed switches as unauthorized. The 40 switch port configuration added to FortiOS and the faceplate shown on the GUI for the switch is based on the information contained in the 40 link discovery frames. Also, if this is the first 40 switch that FortiGate discovers, FortiGate will also configure some additional settings required for 40 switch management, such as the default 40 switch VLANs, their DHCP scopes, and the quarantine replacement messages. Three, the administrator authorizes the switch on the FortiGate GUI, and as a result, FortiOS enables the FSW11 admin setting in the switch configuration. The 40 switch status also changes to offline. The administrator can also authorize the switch on the FortiGate CLI by manually enabling the FSW11 admin setting on the switch configuration, which is under Config Switch Controller Managed Switch. 4. FortiGate sends a 40 link frame to the switch to notify it that it has been authorized. 5. 40 switch loads the default 40 link configuration. Six. 40 switch changes to 40 link mode and A. Creates a 40 link trunk using Auto ISL. The trunk contains the port connected to FortiGate as a member and has the 40 link option set to 1. The latter indicates that the 40 link trunk was created on a switch that was detected using 40 link as the discovery method. B. Starts exchanging 40 link heartbeats with FortiGate for health check purposes. Heartbeats are sent every 3 seconds. 7. 40 switch obtains its IP address and other network parameters from FortiGate through DHCP. The network parameters include FortiGate as NTP server, DNS server, and default gateway. 8. FortiGate adds an A record to its DNS database for the switch. The A record maps the switch serial number to its management IP address. In the example shown on this slide, the switch management IP address is 10.0.13.1. 9. 40 switch uses NTP to synchronize its time with FortiGate. The time must be synchronized between FortiGate and 40 switch for the CAPWAP tunnel to come up. CAPWAP uses DTLS for data encryption. Because DTLS uses certificate-based authentication, a considerable time difference between the two devices will cause a DTLS handshake failure, and as a result, the CAPWAP tunnel will not come up. 10. 40 switch brings up the CAPWAP tunnel. After the CAPWAP tunnel is established successfully, the 40 switch status changes to online. The timestamp when 40 switch comes online is recorded as the join time. 11. FortiGate pushes the configuration to 40 switch using the 40 switch REST API. This connection is made over HTTPS. At this point, the discovery and authorization process is complete. FortiGate and 40 switch continue exchanging data for health check, diagnostics, and configuration synchronization purposes. After you authorize switches, they eventually appear as online on the Managed 40 Switches page on the FortiGate GUI. By default, the page displays the switches in the list view, along with other relevant information for each switch, such as the ID, status, management IP address, and join time. The join time is an important piece of information to review. Under normal operation, a switch join time should remain the same. However, if a switch join time is frequently updated, this may be an indication of connectivity issues between the switch and FortiGate. You can also hover over a switch to see more details, or right-click the device to display a context menu with some actions you can perform on the switch. The page also contains 2 pie charts that report on the switch status and models. The Managed FortiSwitches page also offers 2 other view types, Group and Topology. The Topology view displays a simple but useful topology describing the physical links between switches, as well as the type of links. You can also hover over a port to see more details about the port, such as its status, native and allowed VLANs, operating speed, and spanning tree protocol (STP) state. You can also right-click a switch to display a context menu from which you can select an action, such as editing the switch settings, connecting to the switch CLI, factory resetting the switch, or upgrading the device. You can also display a list of managed switches using the FortiGate CLI. This slide shows the command you can run to get this information. This command provides you with similar information as the list view on the Managed FortiSwitches page, except that it includes a flag column which reports on the device operation status. When you troubleshoot issues on a Managed FortiSwitch virtual stack, you likely start by running the CLI command shown on this slide, because it provides you with an overall status of the switches, including 2 pieces of information that you will likely need to troubleshoot further: the name of the FortiLink interface the virtual stack is connected to and the ID of the switches in the virtual stack. Because FortiGate supports the management of multiple switch virtual stacks and given that each virtual stack can have multiple switches, knowing the FortiLink interface that the virtual stack is connected to and the switch ID of a problematic switch will enable you to filter the output obtained when running troubleshooting commands. This is particularly useful when dealing with large FortiSwitch deployments, because going over the output of all managed switches can be overwhelming. In the example shown on this slide, the FortiLink interface is FortiLink. A managed FortiSwitch can be seen as an extension of FortiGate. In this way, FortiSwitch extends the visibility of the FortiNet security fabric to Layer 2. Using FortiView physical and logical topology views, you can visualize different security segments together with all the stacked FortiSwitch and connected end devices. In the example shown on this slide, the Security Fabric Physical Topology view shows a FortiGate controlling 3 FortiSwitch devices. Note that the physical topology does not show the full physical topology of the FortiSwitch virtual stack. You can view the full physical topology in the Topology view on the Managed FortiSwitches page. You rarely need to access the GUI of a managed switch. However, you can still access it by connecting to the switch from a management workstation on your network. By default, there are no firewall policies configured on FortiGate that allow traffic to the switch virtual stack, so you must configure one for this purpose. Also, by design, the FortiGate GUI hides FortiLink interfaces from the list of available interfaces that you can reference in a firewall policy. This means that you must use the CLI to configure a firewall policy that allows traffic sourced from, or destined to, your switch virtual stack. This slide shows an example of a firewall policy configured on the CLI that allows traffic from a management workstation connected to port 3 on FortiGate to the default FortiLink interface. After you configure the firewall policy, you can access the FortiSwitch GUI by entering the switch management IP address in the browser. Note that by default, FortiSwitch allows only HTTPS access to the GUI, and HTTPS redirection is not supported. This means that you must specify the HTTPS protocol when you enter the address in the browser, or if you want to use HTTP instead, you must manually allow HTTP access on the internal interface. Note that making changes directly on the GUI or CLI of a managed switch is not recommended, because the changes may be lost when FortiGate pushes a configuration to the switch when changes are made to the switch settings on FortiGate. For this reason, you should avoid making changes on FortiSwitch directly, unless the setting is not available on FortiGate, or when the switch operates in standalone mode. You will learn more about standalone mode and the 40 switch GUI in another lesson. The default DHCP scope for the default 40 link interface sets FortiGate as the default gateway, NTP server, and DNS server for its managed switches. The DHCP scope is automatically configured based on the IP address and netmask assigned to the interface. By default, the default 40 link interface is assigned the IP address 10.255.0.1 and the netmask 255.255.0.0. In addition, the DHCP scope is restricted to vendor class identifiers, VCI, 40 switch, and 40 extender. This means that only 40 switch and 40 extender devices can obtain addresses from that scope. For NTP, FortiGate is configured to respond to NTP requests received at the 40 link interface. By default, FortiGate also acts as the DNS server for its managed switches. When you authorize the first 40 switch on FortiGate, FortiOS sets the DNS service setting to local in the DHCP scope configuration of the 40 link interface and adds the 40 link interface to the DNS server configuration, so the interface can respond to incoming DNS queries made by switches. In addition, after the switch obtains its management IP address from FortiGate, FortiOS also adds an A record that maps the switch serial number to the switch management IP address. The result is that the administrator can ping or connect to the switch by using a DNS name that follows the syntax switchid.fsw. When FortiGate discovers the first switch, FortiGate automatically adds some settings to its configuration that are required for switch management. These settings include the following 40 switch VLANs. Default. This is the default native VLAN assigned to all switch ports. Quarantine. This is the default VLAN used for quarantine traffic. On FortiGate, you can quarantine a device that is connected to a switch, and then the device is placed in the quarantine VLAN. RSPAN. This is used for sending encapsulated mirrored traffic across the network. Voice. When using LLDP Media Endpoint Discovery, LLDP MED, you can assign the switch port to this VLAN if the endpoint is detected as a voice device. Video. This is the same as the voice VLAN, but is used when the endpoint is detected as a video device. Onboarding. When Network Access Control (NAC) policies are enabled, this is the VLAN where devices that do not match any of the configured NAC policies are placed. You will learn more about NAC policies in another lesson. NAC_segment. This is used for NAC VLAN segmentation. You will learn more about NAC in another lesson. In addition, a DHCP scope is configured for all VLANs except the default VLAN. Note that the DHCP configuration is not shown on this slide. Finally, the VLANs are also assigned the predefined VLAN IDs shown on this slide, and no administrator access protocols by default. You can edit or delete the default VLANs if required. You will learn more about VLANs and 40 switch VLANs in another lesson. Good job. You now understand managed switch operation. Now, you will learn about managed switch configuration.